Well, good evening. Tonight we're going to go over general technology principles. In later lectures we'll go over specific technology choices and we'll compare various vendors' offerings. But tonight we're just going to look at general technology principles. So the agenda is we'll look first at adoption of technology in general, the organizational impact of technology, and technology adoption. Then we'll look at a technology adoption on virtual teams. Then we'll look at determining the technology needs of a virtual team, then matching technology to team tasks. We'll look at two different case studies, one on the U.S. Army river crossing and the other of a neurosurgery team. We'll then look at principles for collaboration tools by category, and then we'll end up with global technology considerations. So we'll start with just general technology adoption. There are three orders of change caused by the introduction of computer technology. First order effects, and that's substitution. And as an example from my own experience, when we introduced automated workflow tools for formerly manual processes, we did go through these three stages. The initial introduction of these technologies started with first order effects, the substitution of automated document processing for a formerly manual process. Folders had been manually routed and got lost in the system, so to speak. So there was no accountability for someone taking a long period of time to review and take action. Second order effects are increased demand for the technology. Once the introduction of the new technology was finished, it began driving second order effects by increasing the demand of our customers for further automated document processing. So we began numerous projects to deploy these collaboration tools in other locations and for other uses. Basically, automating form processing in new areas. Third order effects are structural change. So with the automated tools, we knew the status of any request at any time and who was currently responsible for taking action. This greatly expedited throughput because the originator knew who to contact when their request had stalled. The use of these deployed systems resulted in enormous savings in time, process cost, as well as the introduction of new uses for the information contained in the managed documents. For example, it was easier to prepare performance reports to show the workload on staff. Ultimately, it led to increased demand in other areas. We introduced the technology by automating procurement requests, and the increased efficiency and convenience resulted in requests to do other workflows as well. There was a great expansion of information technology in the past 15 years where I worked, and 3 years ago the organization was reorganized to delegate authority to lower level units, those that were closer to the customer. It wasn't the introduction of one technology such as electronic document management systems, but I think the cumulative effect of multiple introductions of technology. The increased efficiency caused by these projects resulted in third order effects, new organizational structures better able to deal with customers, and in our case, especially in a time of declining budgets. In my opinion, the following third order effects led to this transformation. Communication flows became horizontal as well as vertical. The more universal yet controlled access to critical information collections also helped drive those third order effects. There was faster decision making by faster retrieval of critical information. Decisions being made closer to the customer through more universal yet controlled access to the information collections again was a driver in the ultimate reorganization. And finally, staff became more focused on supporting the courts rather than spending time on managing routine internal processes. So let's look at technology adoption. Good evening. Tonight we'll talk about technology principles. This is going to be a lecture on the general principles of using technology in virtual teams. We have 2 other lectures later in the series that deal with specific technologies and a comparison of different vendor offerings in each technology category for collaboration on virtual teams. But tonight we'll just look at the general technology principles and how we apply them to global virtual teams. So our agenda, we'll look at the adoption of technology in general, and there's 2 topics here: the organizational impact of technology and the technology adoption process, also known as the diffusion process. Then we'll look at technology adoption on virtual teams. We'll look at determining the technology needs of a virtual team, matching technology to team tasks. Then we'll take a look at 2 different case studies. One, the U.S. Army river crossing, and the next, the neurosurgery team. We'll then discuss the principles for collaboration tools by category, and we'll finish up with looking at the global technology considerations. So let's start with just general technology adoption. So there are 3 orders of change caused by the introduction of computer technology. This is from an article in Scientific American, and 2 individuals did a study on the impact of technology on organizations, and they said there were 3 orders of effect. The first order was substitution. And as an example from my own experience, where we introduced automated workflow tools for formerly manual processes, we experienced these 3 stages. The initial introduction of these technologies started out with first order effects: the substitution of automated document processing for a formerly manual process. Folders had been manually routed and they got lost in the system, so to speak. There was no accountability for someone taking a long period of time to review and take action. The second order effect is increased demand. So the introduction of the electronic document management system technology and the substitution of the automated process for a manual process in the case of procurement requests, in my example, began driving second order effects by increasing demand from our customers for further automated document processing. Numerous projects were begun to deploy these collaboration tools in other locations and for other uses. And it was mainly for automating form processing in the organization. And finally, the third order effects are structural change. With the automated tools, we knew the status of any request at any time and who was currently responsible for taking action. This greatly expedited throughput because the originator knew who to contact when their request had stalled. The use of these deployed systems resulted in enormous savings in time, process costs, as well as the introduction of new uses for the information contained in the documents. For example, it was easier to prepare performance reports to show the workload on staff. Ultimately, it led to increased demand in other areas. We introduced the technology by automating procurement requests, and the increased efficiency and convenience resulted in requests to do other form workflows as well. There has been a great expansion of information technology in the past 15 years where I work, and 3 years ago the organization was reorganized to delegate authority to lower level units, those closer to the customer. It wasn't the introduction of one technology such as electronic document management systems, but instead I think the cumulative effect of multiple introductions of technology. The increased efficiency caused by these projects resulted in third order effects, which was new organizational structures that are better able to deal with customers in a time of declining budgets. In my opinion, the following third order effects led to this transformation. Communication workflows became horizontal as well as vertical. The tools really enabled that. There was more universal yet controlled access to critical information collection. There was faster decision making by faster retrieval of critical information. Decisions were being made closer to the customer through more universal yet controlled access to the information collections. And finally, staff became focused on supporting the courts rather than spending time on managing routine internal processes. So, in addition to the impact of the introduction of technology, we also want to look at the pattern of technology adoption. So there's a pattern on how technology is adopted, and then of course that's going to lead to the three orders of effects once it is adopted. Now, Moore developed a theory on technology adoption, which is also known as the diffusion process, and that has become a classic to explain the pattern of introducing technology into organizations, and it's based on risk, perceived risk. There are 5 categories of people or organizations: innovators, early adopters, early majority, late majority, and laggards. Organizations fit into these categories based on their risk handling capacity. The pattern for adopting innovation in a society is again known as the diffusion process. The general pattern is that the innovator people adopt first, and then we go through the continuum until the laggards finally adopt last. Some groups are more accepting of change than others. Young, affluent, and highly educated groups accept the change more readily. Other factors include the complexity. With more complex products, it takes longer to obtain acceptance. There is a perceived risk that is governing the process. There are 3 elements of this perceived risk. Will the product or approach perform as desired? What are the consequences of it not performing? And number 3, what is the ability to undo any negative consequences? Of course, perception is affected by the group looking at the product as well as the product itself. So innovators are typically a small percentage of the universe. They're about 2.5% in Moore's study. Innovators tend to view introduction of technology as a continuous process rather than discrete events. Innovators are venturesome risk takers. They are capable of absorbing both the financial as well as the social cost of a failure if you introduce an innovative product and it doesn't work. Early adopters are an intermediate percentage of 13.5% in Moore's study, and introduce a new technology to compete with the innovators who have already introduced it. Early adopters are willing to take a calculated risk, but they have concern about the consequences of failure. The early majority are more pragmatic and adopt new technology once leading firms have worked out the bugs and issues. The early majority block of adopters represented about 34% in Moore's studies. The early majority tend to be cautious about innovation. They adopt innovation that has already proven successful with others. The late majority of adopters are risk averse and are guided by their traditional approaches, and they usually sidestep innovation. The late majority follows and generally does not have confidence in their ability to deal effectively with new technology. So they follow the early majority and the innovators and early adopters. They represent the late majority, a block of about 34% of the universe of technology adopters. The late majority are typically skeptical about innovation. They often adopt in response to social pressure or diminishing availability of the old method or product. The laggards, the last group, are skeptical about the alleged benefits of technology. Laggards are the last to adopt, and they may never adopt new technology. They represent about 16% of the universe. They tend to be dogmatic and oriented towards the past. They adopt innovation reluctantly. Well, here is the diffusion curve. And you can see we've got the innovators, 2.5%, early adopters, 13.5%, early majority, late majority, and laggards. And of course, the horizontal axis is time, and the vertical axis is the number of acceptors. With cell phones as an example, the early use of cell phones was following a curve like this. The cell phone was a relatively complex product, and it was not well understood. So it went through this typical diffusion process pattern through these phases. But the iPhone presents a different curve. It compresses the two right phases, the late majority and the laggards. They tend to be much smaller percentages, and the ease of use really of the iPhone resulted in less risk. And remember, what's driving the adoption process is perceived risk. And consequently, because the iPhone was easy to use and relatively low cost, there was a more rapid adoption by innovators, early adopters, and early majority. And of course, when the bulk of society is using something, then even the laggards and late majority move into it. So with that quick introduction into technology adoption in general, let's see how virtual teams have adopted technology. Keep in mind, risk is a throttling factor in the adoption of technology. Gibson and Cohen report that in 2003, adoption of advanced technology was unusual in virtual teams. This may reflect the capacity of these teams to absorb risk, with few early adopters deploying innovative technology along with the relatively new global virtual team organization. Gibson and Cohen found back in 2003 that email and conference call were the primary communication tools. Less used were discussion boards, video tools, and online meeting tools. If we think of perceived risk for the adoption of innovative technology back in 2003, in the case of virtual teams, this risk is higher because it is really the additive impact of two factors. The first is a great deal of risk just reorganizing into a virtual team. Then add on top of that risk of the risk of a complex technology, and the perceived risk of both factors may be too high. Email and teleconference were well understood in 2003, and they had much lower risk. So only teams that could really absorb both the complexity and uncertainty of web convergence technology and the risks of operating in the relatively new organization form of virtual teams, only those teams would use the more advanced technical tools. More recent research finds that virtual teams keep current today with available information sharing and collaboration technology. Even so, familiarity appears to be more important to them in selecting technology than sophisticated features. So today, as we would predict from the diffusion process, more people are using advanced technology to collaborate on virtual teams. Still, because of the risk with virtual teams in general, they tend to favor familiar and usable technologies. Oops. So, studies suggest that training in the technology might help virtual teams gain confidence in their ability to use virtual tools. However, some people are too busy to learn the new technology, while others need individual training and initial support to build their confidence. Training on the technology tools helps reduce risk, but not everybody can devote the time to learn complex new technology, and some may need individual attention. So many virtual teams have a rule to use the least common denominator. In other words, the simplest technology that can accomplish the communication task. The compromise seems to be that the team settles for a level of technology that everybody is comfortable with. So Nissan went one better on training, and in addition to training on the tools, they trained people on how to operate in virtual teams. So conducting training for participating on virtual teams proved to be effective for Nissan. For building familiarity first with virtual team operation, and then for building familiarity in using information sharing and collaboration technology. One of Nissan's courses in this program was how to communicate effectively using collaboration technology. Formal training in the use of technology as part of a virtual team also proved successful for the New South Wales police force. So training on both technology and virtual team operation proved successful for both Nissan and the New South Wales police force in case studies that were conducted. Sabre, which is the yield management and booking system for airlines, it was developed by American Airlines. Sabre tried to resolve the technological risk by selecting people who had knowledge of the technology. So they found that In their early virtual team efforts, they were undermined by choosing people with knowledge of the collaboration tools rather than people best suited to the virtual team mission. The lesson is to choose the right people for the mission and train them on the technology. Choosing people with the knowledge of technology, of course, will not help the team accomplish its mission. You must choose people who have the requisite variety of knowledge to accomplish your mission. The training is a support or administrative function. It's not the main mission of the team. So, let's now look at some general considerations for using technology. Technology in global virtual teams. The linkage through technology is through the technology tools establishing connections to anyone, anywhere, at any time to exchange ideas and information and to organize the activity. There are limitations to technology. Technical tools that establish connections to anywhere at any time do not motivate people to listen, empathize, or establish trust. Technology enables connections, but it does not ensure relationships. And relationships require time and two-way communication. If you'll remember, the LMX partner leadership style is the most productive form of leadership. It is based on establishing relationships. That is the important part of leadership and the important part in harnessing the distributed knowledge of the team to accomplish the mission. Technology can assist, but more critical are the leadership and general communication practices we have discussed in earlier lectures. Cohesion, coordination, and control must be established by defining administrative protocols for effective communication and reducing the barriers to communication we discussed. Just as critical is preparing a communication plan with the selection of the appropriate channel and media for that type of communication. Trust is essential to the success of a virtual team, and this is established through team participation in defining the work processes and changes to those processes. The agreements should be communicated repetitively to reinforce goals, schedule, roles, strategy, and acceptance criteria for the deliverables by the virtual team. The team really has to work at building relationships. The leaders define different social relationships and exchanges. They must progress from a one-way influence for knowledge and social exchanges to emphasize quality and quantity of two-way interactions. The LMX partner level is really a predictor of productivity on virtual teams and general organizations because it has built trust and respect by building relationships. It has built mutuality, in other words, a mutual sharing of obligation and a commitment to the interest of all parties, again, by building relationships. Top leaders consistently move from one way to reciprocal relations, where followers influence leaders as much as leaders influence the team. So this is a digression to recap the important points of leadership and communications. This slide's a good reminder of the important facets of leading virtual teams and that technology is not the real answer to virtual team success. So looking at the boundaries of technology, what how do we find the acceptability of a technology? First, technology for virtual teams must work reliably and simply. Technical problems become the focus of virtual teams rather than the business issues, which should be the focus of the virtual teams. Complex technology may not enhance communication, but it can impede it as people struggle with using the tools. You do not form a virtual team, or you do not create a virtual team because of their expertise in virtual management tools. But at the same hand, but by the same token, experts on a virtual team must be willing to learn the technology chosen to collaborate on the team. So what is reliability? We say technology must work reliably and simply. Reliability is delivering the same result every time you use the product. It is not just freedom from crashing. It is a predictability on the important measure of use, delivering a known result, delivering the desired result in the expected time for the standard cost. A reliable product consistently provides this output. Repeatability is related to reliability, and it's often confused with it. While repeatability looks to accomplish the same predictability, it focuses on inputs, while reliability focuses on the output. An adaptable team can help with repeatability, but reliability is usually from the product vendor. Then we have the other word that we used. We want the technology to work simply. When we say work simply, the technical meaning is usability. When I worked for them, Microsoft had a good test for usability. They would take two test groups, one that had been thoroughly trained and another with no training at all. They would give each group the list of functional tests to perform, and if teams completed the set of tests in approximately the same time, then the product was usable. If the untrained team took substantially longer, then it was back to the drawing boards. The product had failed usability testing. It was not simple to use. So, usability of technology. Again, we need technology that just plain works. The staff does not have time to waste fiddling around with the technology. They need simplicity in the technology, and the team needs a staff that knows how to use it. Reliability of technology. Once technical problems surface, audio, video, bandwidth, you lose focus on the business and start focusing on the technology. The staff needs to focus on the mission and critical issues and not the technology. An often overlooked factor in reliability is country infrastructure. The reliability and availability of communications and steady electricity without brownout, spikes, or other phenomenon. So there's many false assumptions about technical infrastructure that can undermine global virtual teams. So don't assume that the technical infrastructure in your country is the same as that in countries around the world. Technical infrastructure may not be as advanced, but even more often it is different, and this leads to technical issues. And I'll give you my own experience with Citibank Mexico and the failure to record deposits. I was tasked with migrating the Citibank Mexico system from an IBM 4331 series mainframe onto Microsoft's client-server technology. And we had finished the project and done the testing. Everything looked positive. and we went live. And after we went live, occasionally during the days, we would lose depositors' deposits into their savings accounts. And we investigated and investigated, and what we found was where the error was occurring was actually not in the code or in our hardware for the servers, but instead it dealt with the infrastructure, the communications infrastructure in Mexico. In much of Latin America, and this is going back over 20 years ago, they did not have the cable and fiber optic landlines that we have in the United States. And so they substituted instead a lot of satellite communications. And so when we went from landline in the local metropolitan area to go between metropolitan areas, we would go through an X.25 router up to a satellite. So the X.25 protocol is one that's used with satellites, the X.25 communication protocol. So we would, the router would convert TCP/IP into X.25, and then that would go up to the satellite, back down to the router in the destination metropolitan area, where it would be converted from X.25 protocol into TCP/IP. Well, the routers that were originally chosen for the that particular job were not properly, after we investigated, we found out they were not properly repackaging the TCP/IP packets from the X.25 packets. And so there were certain conditions where the packets would be truncated, and that would lead to failures to record the deposits. The solution we found was to get Cisco routers and put them in place. And this was when there was a lot of competition for the router market, and Cisco was a player, but it wasn't as dominant as it is today. But it did have experience in the United States with using satellite communications, because it had been used by a lot of government agencies that use satellites. So that solved the problem. But the point is, the technical infrastructure in the countries you're dealing with may be different. So you have to really consider that when you draw up your decisions on technology. So let's consider some global technology considerations. A major impact on virtual team technology is the potential unreliability of foreign infrastructure, such as their electrical power and telecommunications. Telecommunications are more critical in global projects, yet communication infrastructure may be different in emerging countries, such as China, Africa, and Latin America. And sometimes it's not only different, sometimes it's unreliable. So this risk can be mitigated through the acquisition of multiple communication links, as well as the use of different media. In addition, the number of facilities used overseas should be reduced and concentrated into a few larger facilities located in major population centers that have a good communications infrastructure. Another major impact on virtual team technology is the sovereign risk encountered by global virtual teams. This is the impact of regulatory interference by a foreign government. This can include limited and censored use of the internet and internal wide area networks and telephone and email technology. I experienced this in my consulting engagements in Argentina. Before the internet, there was CompuServe. And this is again going back to the late 80s and early 90s. The internet really took off, I think, in like 1994, but it wasn't like there was no precursor to it. There were precursors, and CompuServe was one of them. And CompuServe, in fact, was one of the first of the wide area networks that had access to the internet. Anyway, CompuServe had great services, and I used them for virtual teamwork I did while at Microsoft. Of course, in the countries where they had Microsoft offices, there was email and internal file servers I could access through my Microsoft remote dial-in connections. But that wasn't everywhere, and CompuServe also had other things that we didn't at Microsoft at that time. For example, extensive forums for developers and other communities so you could post questions, get replies, do file transfers. I used CompuServe extensively. And of course, when the internet came in, I used that extensively. I had a 3-month engagement in Argentina, and that came to a rapid roadblock in that the Argentinian government did not allow unregulated access to CompuServe. You had to get government permission, which was an arduous process, and you really needed political insiders to do that. So I had no chance really of getting that for my work assignment. So imagine, if you will, being cut off from the internet today and trying to do a project. That was what happened to me. So make sure you're aware of government restrictions on the web and international communications in general, and factor that into your technology and your communications plans. So some more considerations. Define your time and resource needs for implementing the tool set. Your management plan must incorporate time and money to implement the virtual management tool set. You can't ignore it. You have to put it into your core plans. It's unproductive for a team to wait for the infrastructure, configuration, software installation, data line, or other technology you need for your collaboration tool infrastructure. Implementing and running the virtual management tool set requires resources, so you have to plan for that. Another consideration is define your technology access. What is the gap between the technology needed in one of the various locations and what actually exists at that location? At the different locations, what technology do the staff use and understand? You have to take that into your consideration as well. Some compatibility considerations. Define your technology's compatibility. Use the categories of information determined in your communication lecture. Well, we went over in the communication lecture, and you will have determined in your communication plan. And have each location prepare a document of each type of information and send it to a sandbox digital workspace. That's a test system that you set up to simulate the type of, say, document storage, forum, or other tools you might be using. Most vendors, you can set up a sandbox in their area that's just a test area and then later take it down. You got to then verify the compatibility by having each location open and read the document types sent by the other locations. Categories of information that you would want to do that with can include office automation documents. You need to validate the content and formatting, graphics, validate your ability to scan graphics, find out if iPhone camera graphics are an acceptable substitute, and that your data line speeds are appropriate for sending graphics. Then also verify your teleconference or video conference technologies. Verify that there are sufficient speakerphones, webcams at each location, and pilot the use of these technologies. So, defining technology compatibility can include things like font availability for documents in different countries. If you're going to be sending documents over in China, you would be looking at very different character sets. Look also for codecs on your videos. Do all the locations support a common codec that you use for your videos? You need to test and find out all of the small incompatibilities and then figure out how to compensate for them. Okay, let's take a break and come back in 5.